SpaceX has won a lot of well-deserved praise and acclaim for its efforts to reduce the cost of rocket launches during the past several years. The Indian Space Research Agency, or ISRO, on the other hand, is a less well-known organization. The cost of missions, including lunar missions, orbital missions, and even Martian missions, has been steadily declining for decades due to the gradual but steady efforts of ISRO. Welcome, and you are watching Technology Zone, where the home of technology resides. So here is a tale of ISRO, the underdog in space. Although ISRO was formally established on August 15, 1969, the organization has a long history. The oldest sources may be found in the works of Indian scientist S.K. In the 1920s, Mitra is well recognized for his ionosphere sounding research efforts, where ionosphere sounding is defined as a communication method for locating the best radio frequency in a particular location. This knowledge aids researchers in their understanding of Earth's near-space environment and upper atmosphere. Other than SK, we also have a CV Mitra. And not only that, but in the 1920s and 1930s, Raman and Meghnad Saha also carried out a number of space-related experiments. But when the Physical Research Laboratory and the Tata Institute of Fundamental Research were established, the principal leading step ahead still would not happen till the 1940s came. Vikram Sarabhai and Homi Bhabha, two scientists, formed these two organizations respectively. Each group made use of adjacent academic institutions and research facilities to carry out testing at high altitudes, upper atmospheric investigations, and cosmic radiation experiments. Prime Minister Nehru was persuaded to create the Indian National Committee for Space Research in 1962 by Vikram Sarabhai. India would soon start experimenting with sounding rockets, which ultimately resulted in the founding of ISRO, the Indian Space Research Organization, in 1969. The Satellite Launch Vehicle, or SLV, was the first of 5 launch vehicles that ISRO has since produced. The SLV was a relatively modest rocket with a 40-kilogram payload limit. Despite being very straightforward, it took ISRO 7 years to create, and regrettably, the initial launch in 1979 would fail despite that. 317 seconds after launch, the rocket would fall into the Bay of Bengal because of a malfunctioning valve. Just 1 year later, in 1980, ISRO attempted the SLV once more. This time, the launching was successful. India became the 6th nation to achieve space when ISRO successfully launched the Rohini RS-1 satellite into orbit. SLV would later be used twice more with varying outcomes. The third launch was successful in and of itself. However, the satellite was placed in a dangerously low orbit, resulting in its deorbiting 9 days after the launch. The fourth launch would occur in 1983, and because this mission was successful, ISRO was able to deploy an Earth observation satellite. Following the SLV's commercial success, ISRO set out to create the ASLV, a more sophisticated variation of the SLV. The 5-stage solid-fuel rocket known as the ASLV was designed to carry payloads to geostationary orbit. Tragically, this rocket would prove to be a huge letdown. The ASLV made 4 successful launches over the course of its existence with 3 failures. The first mishap occurred in 1987 when the rocket's first stage failed to ignite the next launch. Just a year afterward, ISRO attempted again, but the launcher would eventually disintegrate. In 1992, the third ASLV launch would take place. Unlike the SLV error, the satellite would be put into an orbit that was too shallow and end up deorbiting. In 1994, the ASLV would make its 4th and final launch, and this launch was successful. However, considering the ASLV's troubled background, ISRO decided to stop developing the rocket and concentrate its efforts on the PSLV, or Polar Satellite Launch Vehicle. The PSLV was created to launch payloads into Sun-synchronous orbit, and it is this rocket that will serve as the true gauge of ISRO's capabilities. Conversely, the PSLV's initial flight in 1994 would be a disappointment. Nevertheless, PSLV would go on to have a run of 50 successful launches. In fact, the PSLV is still in operation today, and it has successfully launched 342 foreign satellites from 36 different nations into various orbits. The PSLV actually held the record for putting the most satellites into sun-synchronous orbit in a single flight until this year. The PSLV is not only a very reliable launch vehicle, but it is also quite economical. It is anticipated that each launch will cost between $18 and $28 million, but we'll just round it up to a higher estimate of $25 million for each launch. The PSLV costs $6,579 per kilogram and is capable of sending 3,800 kilograms into low Earth orbit. To put that in context, the future SLS rocket from NASA is anticipated to be able to send 70 metric tons into orbit, but it will cost more than $2 billion each launch. Accordingly, the price per kilogram is $28,572, more than 4 times the price of PSLV. Now, PSLV is only around a third as cost-effective as the Falcon 9, which only costs $2,193 per kilogram and is far more expensive overall. Despite this, the PSLV, which was developed in the 1980s and 1990s, is far more efficient than those being developed by NASA today. The Geosynchronous Satellite Launch Vehicle or GSLV was ISRO's subsequent rocket. It does have a payload capacity of 5,000 kilograms and is essentially an upgraded version of the ASLV. 13 launches have been made by the GSLV so far already, with 8 of them being successful, 2 being partial errors, and 3 being total failures. More oversized cargoes are still launched into geostationary transfer orbit using the GSLV nowadays, and that gets us to the GSLV Mark III, the last rocket built by ISRO. The most potent rocket ever constructed by ISRO because it can launch 10,000 kilograms into low Earth orbit. It was created in the early 2000s. The GSLV Mark III is highly cost-effective in terms of its cost per kilogram, much like the PSLV. Each launch of the GSLV Mark III costs $51 million, or $5,100 per kilogram. The GSLV Mark III alone has been launched 4 times and each launch has been successful. In comparison to the earlier days, it appears that ISRO has drastically increased its reliability. Anyway, before we get to important ISRO projects finished with these rockets, let's start with a few satellite initiatives. For example, the IRS series consists of many satellites in a sun-synchronous orbit, and India is able to track and monitor natural resources such as fresh water, big thanks to these satellites. But not just that, the INSAT series is a different set of satellites that ISRO oversees. This organization offers telecommunications and broadcasting services from its position in geostationary transfer orbit. And here's a fun fact. In the Asia-Pacific area, INSAT is the most extensive domestic communications network. Isn't that amazing? Additionally, ISRO has satellites in both the IRNSS and the Gaggan satellite navigation systems. These organizations assist ISRO in India with communications, navigation, surveillance, and a wide range of other tasks. While ISRO satellites are great, its lunar and Martian missions are where things truly become fascinating. India began to concentrate on attempting to send people to the moon after China was able to launch people into space. Launching a probe to the moon was the first phase of this voyage. Chandrayaan-1 was the first probe to demonstrate the presence of water on the moon when ISRO sent it to the moon in 2008 using a modified PSLV. The lunar poles are expected to contain more than 600 billion pounds of ice, according to Chandrayaan-1. The next effort by ISRO wouldn't be until quite some time had passed, but it would be a huge improvement over Chandrayaan-1. A lunar orbiter, rover, and lander created by India themselves were part of Chandrayaan-2, which was launched in 2019 utilizing the GSLV Mark III. The mission's objective was to demonstrate ISRO's capacity to carry out a gentle landing on the surface of the moon. However, a software error would cause the lander to stray from its intended course and strike the moon's surface. With Chandrayaan-3, which is scheduled to launch in 2022, ISRO intends to attempt a smooth landing once more. Now, let's go on to their expedition on Mars, Mangalyaan-1. ISRO launched Mangalyaan-1 to Mars in November 2013, and in September 2014, the probe successfully entered the Martian orbital. Thanks to this success, India became the first nation to reach Martian orbit. But what's even more impressive is that they managed to finish the entire mission for a record low $74 million. To put it this way, the typical cost of a NASA-completed Martian orbital mission is hundreds of million dollars. For instance, the MAVEN mission cost $671 million, the Mars Reconnaissance Orbiter cost $720 million, and the Mars Odyssey mission cost $297 million. The cost of Mangalyaan-1 was essentially less than a tenth of that of the Mars Reconnaissance Orbiter. Clearly, ISRO has gone a long way in lowering the cost of space flight, but they have just merely begun. In the next one, Aditya L1 will be sent to the Sun in 2022. Shukrayan 1 to Venus in 2023 and Mangalyaan 2 to Mars in 2024 according to ISRO's future plans. They also have a trip to Jupiter in mind, although the specifics of that voyage are still unknown. However, the fate of ISRO is particularly promising since their funding continues to grow year after year. In only the previous 10 years, the expenditures of ISROs have quadrupled. And in addition to that, NASA's budget reached its pinnacle 50 years ago. In the end, ISRO is among the most technologically sophisticated space agencies in the world. When it comes to cost effectiveness, they are not quite at SpaceX level, but they are miles ahead of many other government-funded space initiatives. Given this, it won't be long until ISRO puts people in orbit and subsequently on the Moon and Mars. Did you people know how inexpensive ISRO was? Please leave a comment below and please give this a like if you think NASA will soon concentrate on cutting costs for itself. Of course, you should also think about subscribing to our channel, Technology Zone, and ring that notification bell for the updates on our future videos.